All right, we're going to solve this problem using KVL. But as you can see, we have a supernode. The first node we're solving for is V1, which is highlighted in red. And then the second node we'll be solving for is V2, which I'm highlighting in purple. And the reason that 5-volt source is a supernode is because each side of the node, neither one of those is ground. So that's how we know we have a supernode. So start by writing the first equation at the supernode. So we have this 2 amp current source leaving the node. So we have positive 2. And then it's going to be plus V1 over 4 plus V1 over V1 minus V2 over 3. Okay, so that covers this way over the 4 ohm resistor, over the 3 ohm resistor. Now we have that 5-volt source. So now all you do is in the same equation, we're going to swap to blue to start writing for V2. So then it's going to be plus V2 over 6, then plus V2 minus V1 over 3 as well. And those are, that's the first equation. We have to set this equal to 0. And now we have one equation, but we still have 2 unknowns. So the second equation is going to come from the supernode itself. So remember, we had that 5-volt voltage source right here. So the equation for it is V1 minus V2 to be equal to 5 volts. And it's V1 minus V2 because we got the voltage drop from V1 to V2 denoted by the plus and minus in the voltage source line. And so I went ahead and entered this in my calculator and just making sure it checks out. Yep. And solve this. You can use any online software like Wolfram Alpha or put in your calculator, but V1, sorry, to be negative 2.8 volts. And then V2 should be negative 7.8 volts. And that's your answer.